So here we're going to do a review of identities, of trig identities, and our basic identities are going to be our Pythagorean identity. So sine squared plus cos squared equals 1, tan squared plus 1 equals secant squared, and 1 plus cotan squared equals cosecant squared. Really the main one is going to be this. In fact, we can establish the other identities from this main identity here. Okay, so this is our main identity, cos squared plus sine squared equals 1. We also have our sum and difference identities. Okay, you don't need to memorize these, but it's good to know them. If we need them, we'll probably use a formula sheet to establish them. This tan identity you may or may not have seen before, but this is a sum of angles. The tan of a sum is tan A plus tan B over 1 minus tan A times tan B. Our double angles look like this. Okay, and we also have half angle identities, and these ones you may or may not have seen before, but these ones are useful. And these half angle identities, just so that you understand where they come from, the half angle identities come from the cos 2 alpha identity. So we're going to solve for that sine alpha, and that gives us this half angle. So instead of using 2a, we use a, and a becomes half a. The other angle, the other half angle identity is cosine, this one here. And this one comes from the same equation. Okay, so we're going to use a angle a here, and then this becomes a half a, and then we rearrange to get that expression for half angle cos. Okay, so if you're wondering where these two come from, they actually just come from rearrangements of this identity here. So let's apply a couple of these identities. We have tan of 2 alpha. So we're going to look at these identities and figure out which one we should use. We're going to use a tan A plus B because we can rearrange this or rewrite it as A plus A. There's actually a double angle identity for tan, which is just based on that, but we can just use this one here. It's much easier just to remember one identity and apply it to both. So we're going to have tan A plus tan A all over 1 minus tan A times tan A. Okay, so there's my identity. So to work out this identity, I'm just going to simplify this here. We get 2 tan A over 1 minus tan squared A. I want to just convert this. So I need to use this sine A to establish what tan A is. So I'm just going to do it over here. So if sine A is in quadrant 1, and sine A is going to be 4 over 5, we use Pythagoras to get the third side, and we can see that we have, so this is angle A, we can see that we can find tan A then, and once we have the tan A, we can just plug it into our identity. So 2 times 4 over 3 divided by 1 minus 4 over 3 squared. Okay, so when we work out that numerical value is going to be 8 over 3 over, and that's going to be 16 over 9. So 9 over 9 minus 16 over 9, I get negative 7 over 9. Okay, just double checking that work. That looks pretty good. Okay, so I'm going to end up with, looks like 8 times 9 on top, 3 times negative 7 on bottom. Cancel some common factors. We're going to end up with 24 over negative 7. Okay, so there's the tan of the double angle, the double angle of that angle alpha, or not alpha, but angle A. Okay, so let's look at the cosine. This is using the half angle identity, so I'm just going to use that identity up here. Okay, it's 1 plus cos alpha over 2 square root. So we're going to do this. So it's plus minus. So we can establish whether it's plus or minus by just kind of figuring out where it's located. So here, angle A is in quadrant 1. So if I divide by 2, if I want the cosine of half that angle, I'm going to still be in quadrant 1. So I'm not going to use a plus minus. I'm just going to use a plus case because I can establish where that angle is located. So it's going to be 1 plus cosine of A over 2. Okay, so when we plug that in, cosine of A is 3 over 5. So we get positive square root 1 plus 3 over 5 divided by 2. And that works out to be, that's going to be 2/5 divided by 10, or sorry, 8/5 divided by 10, or divided by 2. 8/5 divided by 2 is going to be 4/5 square root. Okay, so it's going to be 2 over root 5 when I simplify that down. Okay, just double checking my work here. Yeah, 1 plus 2/5, 3/5 is 8 over 5 divided by 2, 4 over 5. Yeah, that looks like it's correct.